Hi everyone and welcome back to NileCertify. In this video, we will discuss Domain 4 in Azure 104, which is networking. And without further ado, let's go to our first question. So here, the question says you need to connect two virtual networks that are located in different subscriptions. Which statement about virtual network peering is correct? A. You can peer the VNets only if they are in the same Azure region. B. Virtual network peering automatically enables transitive connectivity between peered VNets. C. You cannot enable peering if the virtual network's address space overlap. And D. Peering encrypts traffic by creating a VPN connection between the VNets. And in this question, let's see here the options. And before that, here what we have basically, we need to peer to VNets that live in different subscriptions. And option A says you can peer the VNets only if they are in the same Azure region, and this is not correct, right? So Azure supports global virtual network peering, which means you can connect VNets across different regions. And they might be like a small difference in latency and pricing, but technically it's fully supported. So A is out. Option B, virtual network peering automatically enables transitive connectivity between peered VNets. And this actually sounds tempting, but also it's not true. And Azure VNet peering is not transitive by design, right? So that's mean if VNet A is peered with B and B is peered with C, A and C cannot talk to each other by default unless you explicitly set up peering between them as well. So remember, no automatic transitive routing in peering. It's not something that get enabled by default. Okay, option C, you cannot enable peering if the virtual network address spaces overlap. And this is the correct one, right? If you have two VNets have overlapping IP address ranges, Azure will block the peering because it cannot properly route traffic between them. So before you peer, always make sure the CIDR ranges don't overlap. Now just let's have a look at option D, and it says here peering encrypts traffic by creating VPN connection between the VNets. And this also is incorrect. VNet peering uses Microsoft backbone network, not the VPN tunnels. And traffic stays private inside Azure infrastructure, but it's not encrypted by default like a VPN. So if you need an encryption, you would go for a VPN connection instead. So here, what we can take away from this question is that you can peer across regions and subscriptions, and that's actually called global peering. And no overlapping address spaces or the peering will fail, right? And no transitive routing between VNets, and also no VPN or encryption involved in basic VNet peering. So the right answer here is C. Question 2. You are assigning a public IP address to a new VM. The address must remain the same even if the VM is stopped or deallocated. Which combination of allocation method and SKU should you choose? A. Static allocation with a standard public IP. B. Dynamic allocation with the basic public IP. C. Dynamic allocation with a standard public IP. D. Static allocation with the basic public IP. And here, the question basically says that we are assigning public IP address to a new virtual machine. And the key phrase that jumps right away is the address must remain in the same the address must remain the same even if the VM is stopped or deallocated, right? So the address must stay the same. This hints actually tell me that we are talking about static allocation. Correct? Because dynamic allocation, that means you will get new IP address every time you stop or restart your VM. So now we need to know, like, the allocation method should be static. And let's now figure out which SKU, basic or standard, fits best. So option A, static allocation with a standard public IP. We already concluded it must be static, and standard SKU is the newer, more reliable version that keeps the IP even when the VM is stopped or deallocated. So the combination checks both boxes, static and persistent, and we will hold into this one. It's likely correct, but also it's good to go through the other options. Option B, dynamic allocation with the basic public IP. Now, dynamic is the opposite of what we need, and dynamic means Azure gives the IP only while the VM is running. Once you stop or deallocate it, that IP can change. Plus, basic SKU doesn't guarantee address reservation. So this is completely fails the must remain the same requirement, and this is why it's the wrong answer. Option C, dynamic allocation with the standard public IP. Again, dynamic means temporary, and it's wrong. And option D, static allocation with the public IP. And this one has a static, which is good, but the catch here, it has basic SKU. And even with a static address, it can be released if the VM is deallocated when you have basic SKU. That makes it unreliable for scenario where you need a guaranteed persistent public IP. So we will stick with our answer number A, static allocation with the standard public IP. And just the takeaway here, when once you see this phrase here, the address must remain the same, that immediately points to static allocation. Next question. You need to secure access from a VNet to an Azure storage account. Which two statements describe how service endpoints differ from private endpoints? Choose two. A. Service endpoint uses the VNet's private IP and extends the VNet identity to the service. B. A private endpoint is the NIC with a private IP from your VNet that connects privately to the resource. C. Service endpoints still use a service public IP address even though traffic travels over the Azure backbone network. D. Private endpoints can be accessed from on-premises network via VPN express route, whereas service endpoints cannot. Alright, so let's dive into this one. Here, we need to secure access from a virtual network to an Azure storage account. And the question asks, which two statements describe how the service endpoint differ from the private endpoint? And this is one of the questions that test how well you understand the difference between the old way of doing things, which is a service endpoint, and the newer, more secure way, a private endpoint. So here we have two clues in the question. First clue is securing access from a VNet to a storage account. So we are talking about network level access to a PaaS service, in this case storage. The second clue is how service endpoints differ from private endpoints. And that means we are comparing the two, not describing them individually. And let's first understand the two. What exactly is a service endpoint? So service endpoint route traffic from your VNet to Azure service over the Azure backbone network. The path is private, but the service still uses its public IP. So it's secure but not fully private. And then we have the private endpoints on the other hand, which create a private IP inside your subnet using a real NIC. The Azure service now behaves as if it's sitting inside your VNet. and you can even reach it from on-premises over VPN or express route. So focus on what changes between them: the IP used, the routing path, and accessibility from on-premises. Now let's go through the option. Option A service endpoint uses the VNet's private IP and extends the VNet's identity to the service. And this one is partly correct, but slightly misleading. A service endpoint does not use your VM's private IP directly. Instead, it extends the VNet identity to the Azure service over the Azure backbone network. And that means your traffic still reaches the service public IP, but it's tagged as coming from your VNet. So the extend the VNet identity part is true, but the phrase uses the VNet private IP is off. And this one is half true, but not fully accurate for this question. Option B, private endpoint is the NIC with a private IP from your VNet that connects privately to the resource. And this one is absolutely correct, but it's describing a private endpoint, not a service endpoint. And private endpoint use a private IP from your subnet and create a real network interface NIC for the service. And that's a major evolution because now your storage account behaves as it's inside your VNet. So this helps us clarify the contrast, but it's one of the two that describe how service endpoint differ, and it's a more of a background definition. Option C, service endpoints still use the service public IP address, even though traffic travels over Azure backbone network. And that's spot on. This is one of the biggest difference. With service endpoints, the connection is secured inside Azure backbone, but the service still uses a public IP. So even though the path is private, the endpoint is public facing. And that's exactly why private endpoints were introduced, right? To give you a truly private IP based connection. So C is definitely correct. And option D, private endpoint can be accessed from on-premises network via VPN or express route, whereas service endpoints cannot. And this one is also correct, and it's very important distinction because private endpoints live inside your VNets with private IP, and they can be reached from your on-premises network through VPN or express route. So service endpoints can't do that. They only work from inside the Azure VNet itself. And D is our second correct statement. So correct answer are C and D. And just to sum up, service endpoint use the service public IP. They extend your VNet identity and work only within Azure. Correct? Private endpoints, on the other hand, they use a private IP inside your subnet and they create a NIC and can be accessed from a VPN or express route. If you see the word private IP, think private endpoint. If you see public IP but secured over Azure backbone, think service endpoint. Question 4. Which two statements about application security group are correct? Choose two. A. Application security groups allow grouping of NICs so that network security rules can reference the group rather than individual IP addresses. B. Network interface can belong to multiple application security groups within the same virtual network. And C. Application security groups can be used to group resources across different virtual networks. And D. Application security groups automatically apply security rules across all regions without configuration. Okay, so let's talk about security or application security group. The question here says, which two statements about them are correct? So we are looking for tools that describe how application security groups actually work within or inside Azure networking. And I would like you to think of application security groups as labels for network interfaces. So instead of creating firewall rules for individual IPs, you group your VMs into logical buckets like web servers or app servers or database servers. Then your network security group rules can say something like allow traffic from web servers to database servers on port 1433. It makes management much simpler, especially in large environment. So now let's go and discuss the options. Option A, application security groups allow grouping of NICs so that network security rule can reference the group rather than an individual IP addresses. And this is 100% correct. That's literally what application security groups are for. They let you group NICs and write network security groups based on groups instead of IPs and make everyone's lives easy. If you ever see simplify network security management or avoid static IP dependencies, most likely this is about application security group. Option B, a network interface can belong to a multiple application security group within the same virtual network. And this one also correct. A single NIC can be part of multiple application security groups as long as all those application security groups are in the same VNet. And that's helpful when a VM play multiple roles. For example, part of web servers and monitoring agents. Right, so option C, application security groups can be used to group resources across different virtual network. So application security group are scoped to a single virtual network, and you cannot group NICs across VNets, even if they are paired. Each VNet has its own application security group set, so this is incorrect. Option D, application security group automatically applies security rules across all regions without configurations. This one also false because application security groups don't automatically replicate or apply globally. They work only within their specific region and VNets. So correct answer are A and B. Moving to the next question. You need to restrict access to a storage account so that only VMs in your VNets can connect. Does this solution meet the goal? The proposed solution enables a service endpoint for Azure storage on the VNet and make no other changes. Alright, so let's look at this one carefully. Here, we need to restrict access to a storage account so that only VMs in your VNets can connect. The proposed solution says enable a service endpoint for Azure storage on the VNets. And the key phrase here, only VMs in your VNet can connect. And that means we want to block all traffic except from that VNet. So the question is, if we just enable a service endpoint without touching the storage account firewall, does that automatically restrict access? And when you enable a service endpoint, Azure routes your traffic privately over Azure Backbone Network. But by default, the storage account still allows public access from everywhere. This means you only get the true restriction when you also update the firewall setting of the storage account to allow only that VNets. So the service endpoint by itself doesn't meet the goal. It makes the connection secure but not restricted. The answer is no, this solution does not meet the goal. Question 6. Arrange these steps to route all outbound internet-bound traffic from a subnet through a network virtual appliance using a user-defined route. And the steps are A. Enable IP forwarding on the NVA network interface. B. Create a route table in Azure. C. Associate the route table with the subnet. D. Add a custom route with the address prefix 000 and next hop type appliance specifying the NVA IP. Alright, so let's walk through this one step by step. You need to route all outbound internet-bound traffic from a subnet through a network virtual appliance, or NVA, user-defined route, and or also known as UDR, right? And the question give us here for action and ask for the correct order. So let's understand what's happening here. And what exactly is the NVA? NVA is a virtual machine that acts like a firewall, proxy, or router. And to make your subnet send all traffic through it, you have to create a route table and tell Azure for anything going to the internet, send it to the appliance, to this appliance first, right? And now let's go through each step and arrange them logically. Okay, so when you have network virtual appliance, the first step you want to do is to enable IP forwarding on the NVA network interface. And this comes first because your NVA must be able to receive and forward traffic that's not originally addressed to it. And by default, Azure VMs drop such traffic. So enabling IP forwarding is what turns your NVA into an actual router. Step 2, create a route table in Azure. Next, you need a route table, the container that will hold your custom routes. This is where you will define how traffic should be directed. Step 3, add a custom route with the address prefix 0.0.0/0 and next hop type virtual appliance, specifying the NVA IP. Now that you have a route table, you add a custom route. The prefix 000 those 4 zeros/0 means all outbound traffic, right? This is important. You need to understand what does it means. And setting the next hop to virtual appliance, tell Azure to send all that traffic to the NVA private IP address. So I hope this is clear. Step 4, associate the route table with the subnet. Finally, you associate this route table with the subnet you want to control. And until you do this, the route table doesn't apply to any traffic. Once associated, every VM in that subnet will send its outbound traffic through the NVA. So the correct order is enable IP forwarding on the NVA NIC, 2, create a route table in Azure, 3, add the custom route, 4, associate the route table with a subnet. Question 7. Select the effective action for inbound TCP traffic on port 443 given this NCG's rule processed by ascending priority. Rule 1, priority 200, source any protocol TCP, destination any port 443 deny. Rule 2, priority 300, source virtual network protocol TCP, destination any port 443, allow default NCG rules apply. And the choices are first one, all inbound TCP 443 traffic is allowed due to the virtual network allow rule. B, all inbound TCP 443 traffic is denied due to higher priority deny rule. C, inbound TCP 443 traffic from the internet is allowed but traffic from the VNet is denied. D, inbound TCP 443 traffic from the internet is denied but traffic from the VNet is allowed. Alright, this one is all about NCG rule priorities. A common topic in the Azure Administrator exam, and here the question says select the effective action for inbound TCP traffic on port 443 given these NCG rules. And we have got 2 custom rules. Rule 1, priority 200, source any, and the rule 2, which we just mentioned. And so let's first read the question carefully. And the question here says processed by ascending priority. And that means the smaller the number, the higher the priority. And so rule 200 will run before rule 300. Now rule 200 says deny all TCP 443 traffic from any source. That's global deny. It blocks everything hitting port 443. We would like to apply this logic. and since the deny rule applied to any source, it will catch the traffic first before Azure even gets to the allow rule. So even the rule 2 says allow from a virtual network, it's at priority 300, which is lower, and that means it never get evaluated because the deny rule has already matched the packet. So step 3, we just like eliminate the wrong choices from what like we breach, right? And that's mean all inbound TCP 43 traffic is allowed due to the virtual network rule. That means wrong, right? And here, by applying this logic, just to save you sometimes, we'll have only one potential answer, which is all inbound TCP 443 traffic is denied due to the higher priority deny rule. So that's the correct answer. And just remember, network security group rules are processed in order of priority, lower number, higher priority. And once a rule matches, no further rules are checked. A deny with a lower priority number always wins over an allow with the higher one. This is important. Deny with the lower priority wins over allow with the higher priority number. Moving to the next question. Which statement about Azure Bastion is true? A. Bastion installs on each VM and require a public IP on the VM. B. Bastion provides RDP and SSH connectivity through the Azure portal without exposing public IP addresses. C. Bastion is a load balancer that distributes web traffic across VM instances. D. Bastion must be deployed separately in each Azure region to manage VMs. So let's talk about Azure Bastion, and it's one of those services that keeps your virtual machine secure while still giving you easy access. And let's go through the options. So option A says Bastion installs on each VM and requires a public IP on the VM. And that's wrong. Azure Bastion doesn't install in your VMs. It's actually managed PaaS service that you deploy to a virtual network and not to individual machines. In fact, the whole point of Bastion is to avoid giving your VMs public IPs in the first place. Option B, Bastion provides RDP and SSH connectivity through the Azure portal without exposing public IP addresses. And this one is correct. And this is exactly what Azure Bastion does. It lets you connect to your VMs, Windows or Linux, directly through the Azure portal using RDP or SSH all over TLS. Your VMs may stay private and you don't have to open ports like 3389 or 22 to the internet. So secure and convenient, that's the whole reason Bastion exists. Option C, Bastion is a load balancer that distributes web traffic across VM instances. And that's incorrect. That's describing Azure load balancer, not Bastion. And Bastion doesn't handle web traffic, it handles management connection to VMs. Option D, Bastion must be deployed separately in each Azure region to manage VMs. And this one partly true but not misleading. But misleading, sorry. Because you do deploy Bastion per virtual network, not necessarily per region. If your VNet spans per network, the Bastion host can handle all of them within that connected space. So it's not a per region requirement. And the correct answer is B. Bastion provides RDP and SSH connectivity through the Azure portal without exposing public IP addresses. Question 9. Which statements about Azure private DNS zones with auto-registration is correct? And before we going into the option, so here we are talking about auto-registration is enabled, and we have Azure private DNS, right, with auto-registration is enabled. So Azure private DNS zones are used to resolve domain names privately inside your virtual network. That's the whole point of using them. You don't want to expose them to the public internet. And when you enable auto registration, Azure automatically updates DNS records whenever VMs are created or deleted without any manual work is being needed. With that in mind, let's look at the options now. Option a virtual network can link to multiple private DNS zones with auto registration enabled. And that's incorrect. A VNet can be linked to multiple DNS zones, but only one of those links can have auto registration turned on. You can't have multiple zones auto registering from the same VNets because Azure blocks that to avoid duplicate record conflict. Option B, private DNS automatically registers and manages host names for VMs in linked VNets. And that's correct. When you link a VNet to private DNS zone with auto registration, Azure automatically creates A records for your VMs and keeps them updated. If you delete or move a VM, the records get updated too. So this is a statement that matches exactly what auto registration does. Option C, private DNS zones cannot resolve names across peer VNet. And this one is incorrect because they actually can as long as the peer VNet is linked to the same private DNS zones either directly or through auto registration from another VNet. So cross VNet's name resolution is supported. Option D, you must configure your own DNS server to use private DNS. And this one is wrong as well because there's no need for that. And what makes Azure private DNS convenience is exactly this. It's fully managed by Azure and you don't need to run your own DNS server. So the correct answer is B. And the takeaway from here is a VNet can link to many private DNS zones, but only one can have auto registration enabled. With auto registration, Azure automatically creates and updates DNS records for your VMs. Private DNS zones can resolve names across peer VNets as long as they are linked. And there is no need to manage your own DNS server. Now we reach the conclusion of our session today. Please, if you gain any value, share this content with someone who might find it useful and give us like, subscribe, comment. I really appreciate all the people who are commenting. Thank you so much for being a part of this channel and good luck with your exam and with your life. Thank you so much.